everybody, for your first lesson for Chapter 1, Lesson 1 in 7th grade, we're going to be talking about rates. One of our objectives for this lesson is we need to be able to find what a unit rate is. The standards we're going to address is Standard 7, Ratios and Proportions, Standard 2, 7th grade standard, Ratios and Proportions, Standard 2B. In this lesson, we're going to have two vocab words. The two vocab words are very important words that we're going to be using all throughout the lesson. The two words are rate and unit rate. All a rate is a ratio in which it compares two different quantities. A ratio is just another fancy word for a fraction. So whenever we're writing a rate, we're actually writing it as a fraction. A unit rate is when a rate is simplified so the denominator is 1. What that means is we're actually going to change our fraction, or a rate, so it becomes a unit rate by dividing the bottom so we can change it to the number 1. And what we do in math is whatever we do to the bottom, we have to do to the top. For our first example, what I'd like you to do is I'd like you to take time to maybe pause the video, write this question down. We're going to go through it here in a few seconds. This question right here says that John biked 20 miles in 4 hours. If he biked at a constant rate, how many miles did he bike in 1 hour? So we know that it's going to be dealing with rates because we see in the problem it talks about a constant rate. What we have to do is we actually have to make it a rate and then simplify it down into unit rate because it says 1 hour. The 1 is hinting that the rate is going to be talking about hours, but that hour has to be 1. So we need to change it so that our denominator becomes 1 to make it a unit rate. So the first thing we do is we look back at the problem and we're going to write our information as a rate and then we'll change it to a unit rate. John biked 20 miles in 4 hours. So if I was going to write 20 miles in 4 hours, I see that I have miles, I have hours. It's two different things. We can make that a rate by just writing it as a fraction. 20 miles, 4 hours. I know that I want hours on bottom because remember our denominator is on bottom. And when we're writing a unit rate, we always want our denominator to change to number 1. One of the things I talked about when you guys were doing your vocab is I said that when you're changing to a unit rate, you want to divide the denominator by itself to change it to number 1. So 4 divided by 4 equals 1. Now the bottom, or our denominator, is talking about 1 hour. In math though, if we do something to the bottom of a fraction, we actually have to do it to the top as well. So we can't just divide the bottom by 4, we also have to divide the top by 4. 20 divided by 4 equals 5. So in this problem, if somebody was going 20 miles in 4 hours, they're really going an average speed of 5 miles each 1 hour. And the reason why we're able to divide by 4 over 4 is 4 divided by 4 is actually the number 1. So whenever we divide by 1, we're not really changing a fraction. We're keeping it itself, we're just simplifying it down. 4 divided by 4 again is 1. 20 divided by 4, that's 5. 4 divided by 4, that's 1. We're able to simplify the fraction down and get to a unit rate. This is the unit rate, and I know it's a unit because if we look, again, our denominator is 1. Very, very important that we know a unit rate is when the denominator is 1. To get there, all we got to do is divide the bottom by itself, and if we do it to the bottom, got to do it to the top. For our second example, what we're going to look at is we're going to look at reading. This example, I would like you again, pause the video, write the question down in your notebook. If you feel like you can maybe solve it based on how we solved example 1, that's great. Try it on your own before you actually play the video. We're going to go ahead and solve this problem. It says Victoria reads 72 pages in 3 hours. What is the average number of pages that she reads per hour? So right now, we need to first write a rate, kind of like we did our first problem. 72 pages in 3 hours. So I'm going to write 72 pages over 3 hours. This right here is a rate because it's a comparison between two things, pages and hours. But it says how many pages did she read per hour? Since I see the word per, that usually infers 1 or each hour. So I need to change my hours to 1. What we learned in our first problem was if we're ever changing whatever the denominator is to 1, all we got to do is divide the bottom by the same number. 3 divided by 3 equals 1. And reminder, if we do it to the bottom of a problem, we also have to do it to the top of the problem. 72 divided by 3 equals 24. That's something I knew off the top of my head. If you maybe struggle with 72 divided by 3, you could go to long division, or you could even use a calculator to just double check your work. We will be using a calculator in these lessons sometimes because the decimals that we're going to get aren't just necessarily always going to work out to be an easy number. So have your calculator ready for the next few problems because we're probably going to need that. For example 3, I'd like you to pause the video, go ahead and copy down this question. If at all possible, I would love it if you could actually pause the video and try this question completely on your own based on how we answered the first 2. I'm going to go ahead and answer this question, kind of help you out. Pay attention. Maybe if you don't understand this, will help you out. Find the unit price, or how much it costs per can, if it costs $4 for a pack of 12 cans. So I'm thinking about the price of something, and I'm trying to figure out what it costs for each can, or per can. So in this case, I'm going to write my rate so that cans are on the bottom, because if I'm looking at that, my denominator has to be the unit rate. Per can means I'm going to get 1 can on bottom. So right now I know it's $4 for 12 cans. The 12 cans has to be my denominator, where the 4, that's the other piece of information, will go and be my numerator. So it's $4 for 12 cans. Our job again is to change the 12 so it becomes a 1 on the denominator. Reminder, as we did in the first 2 problems, we're going to divide the top and the bottom by this denominator to change it to unit rate. 12 divided by 12 equals 1. 4 divided by 12. Now this one is $4 divided by 12. I really don't know that off the top of my head, so what I'm going to do is I'm actually going to use my calculator to figure out what that decimal might be. 4 divided by 12 equals, I'm looking at my calculator right here, and it says 0.33333. Well, we're talking about money, and money doesn't go that far. Money actually goes to the hundreds place. So I'm actually going to only go to the hundreds place, but I'm actually going to write it in the thousands place to know whether or not I round the hundreds up or I round the hundreds down. So it says 0.333. Now that's the thousands, the third number right there. We're rounding to the hundreds because money only goes into the hundreds. It takes 100 pennies to make $1. So we look at this 3, we look to the right of it. Since that number is less than 5, we're actually going to just take it off. If it was more than 5, we would round this number up to a 4. But again, 3 was less than 5, so we're actually just going to drop it off. It costs 33 cents for every can if it costs $4 for 12 cans. And this is our unit rate for this problem. For our 4th example, again, I'd like you to pause the video, write down the problem. This one we're talking about bottles of water. We're still finding a unit rate because if we read the question, it says, find the unit price per bottle of water if it costs $6.99 for a 24 pack of water. Round to the nearest hundredth if necessary. So what I'm going to do first is I'm going to write my rate. $6.99 for 24 bottles. I know that's the price for 24. Again, they want us to figure out what is the price per bottle. I see per bottle. That's automatically telling me that bottle is what should be on the bottom of my ratio. So I'm going to do what I did in the past. I'm going to divide by 24 and divide by 24. Remember, if you have to do it to the bottom, you have to also do it to the top. 24 divided by 24 is 1 bottle. $6.99 divided by 24, I don't know that. I'm going to use my calculator to double check. $6.99 divided by 24, and if I look at my calculator, I get 0.29125. Well, it says round to the nearest hundredth. And again, that's because money only goes to the hundred spot. But it's important to include the thousands until you actually round. So I'm going to copy down to the thousands. 0.291. The hundreds is the second place right after the decimal. 0.29. This is the tenths, that's the hundreds, that's the thousands. So I only need to go 3 spots behind the decimal, but now I'm only going to bring it down to 2. So I need to look at the 9. I look to the right of the 9, that's a 1. A 1 is less than 5. Since that's less than 5, we're just going to drop that off. If that was more than 5, we would round the 9 up. We don't have to in this case. 29 cents for each bottle if it costs $6.99 for 24 bottles. This is about the average price. Now it's an average because we've actually rounded, so not exactly the price. Here we are at example 5. There's only 2 more problems to do. Let's go ahead and pause the video, copy down everything that we see on the board, and then we're going to go ahead and solve this problem. After we get done solving this one, I want you to try the next one on your own. So pause the video, try to do everything that you can, and then try to see what happens. The prices of 3 different bags of dog food are given in the table. Which size bag has the lowest price per pound? We're going to round it to the nearest cent. So reading this question, I already see that I see the word per pound. That means pounds are going to be what we change to our unit rate. Since it's going to be our unit rate, it needs to be on the bottom of our fraction. So I'm going to write that it's $49 because it's not the unit rate over 40 pounds. And again, we have to change that 40 so it becomes the number 1. As we did in all of our other examples, we need to just divide the bottom by 40, and we do it also to the top. $40 divided by 40 equals 1 pound. So I figured out what the price is for 1 pound here in the next second. $49 divided by 40. I really don't know. I'm going to go ahead and type it in the calculator. 49 divided by 40. And my calculator actually says 1.225. I'm actually going to copy that entire number down. 1.225. This doesn't look like money, and money goes to 2 decimal places. So I'm going to put my finger where the second decimal place would be. I'm going to look to the right. That number is 5. Now, as we talked in the past, if it's 5 or more, the number in front of it's going to round up. If it's less than 5, we're just going to drop it off. But since this number is at 5, we're going to change that 2 to 3. That means the first bag of dog food actually cost $1.23 for 1 pound. Now, we're not done though, because it says which bag of dog food has the cheapest price. So we actually have to look at all 3 problems to figure out which one's the cheapest. So let's go ahead and do the next one. It costs $23.44 for 20 pounds of dog food. It's our job again to get to 1 pound. So we're going to divide by 20, divide by 20, 20 divided by 20 changes it to 1. So we've got our 1 pound. 23.44 divided by 20, I'm going to use the calculator again. And what I get in my calculator is 1.172. So I'm going to copy that down. Well, we look to the right of the 7, because again we're going 2 decimal places. That's a 2. That's less than 5. We're going to go ahead and drop that off. So right now, I can tell you that the second bag of dog food costs $1.17 for 1 pound. Let's do the very final one. It's $9.88 for 8 pounds. $9.88 for 8 pounds. And it's important to have labels, so I need to put that money sign up there. Again, we want to change pounds to number 1, so we're going to divide the top and the bottom by the bottom number. Divided by 8. Divided by 8. 8 divided by 8. That's 1 pound. And 9.88 divided by 8 gives me 1.235. And if you don't believe me, check it in your calculator. You should see the same decimal. So I'm going to copy down 1.235. Money again, second decimal. We look at the 3. We look to the right of it. That's a 5. That 5 means we're going to round that 3 up to a 4. So I'm going to erase this, and I'm going to go ahead and put a 4 there. So now looking at this, the cheapest bag of dog food, it's $1.23 for 1 pound in the 40-pound bag. It's $1.17 for 1 pound in the 20-pound bag. And it's $1.24 for 1 pound in the 8-pound bag. So if I was shopping and I wanted to figure out what one's going to be the cheapest for me per pound, then that means the second bag of dog food is the one that I would want to go with because it's $1.17, which is a little bit cheaper than all the other ones. Alright, congratulations, you made it to the last question. What I'd like you to do is I'd like you to pause the video, copy everything that you see down on the board, and try this question on your own if at all possible. We've already went over a bunch of examples, so this should be pretty good and pretty simple. I'm going to go ahead and solve this, so if you need to do it on your own, go ahead and keep it paused and wait till you're done, and then hit play, and then check to see if you got the right answer. This question here says that the times for 3 runners in 3 different races are given in the table. Which runner finished the race with the fastest time per kilometer? So it's our job to change the kilometers to 1 because it says per kilometer. So what we're going to do is we're going to look at all 3 runners and we're going to change their distance to 1 kilometer. Since kilometers is going to change to 1, that's what we want to put on the bottom or denominator. That means time or minutes is going to be on the top. So I'm going to write each one of these as a fraction, but first I'm going to write the letter that represents a runner so I know which runner I'm talking about. 34 minutes over 5 kilometers. Runner A goes 34 minutes and they go a distance of 5 kilometers. Our job is to figure out how fast they go 1 kilometer. So what we're going to do is what we did in the past. We're going to divide by 5 on bottom, and if we do it to the bottom, we're also going to do it to the top. 5 divided by 5 goes to 1, so I can't write a kilometer very well, 1 kilometer. And 34 divided by 5, I'm going to type that in the calculator, 34 divided by 5, and I'm going to get 6.8. So I'm going to keep the label the same. If a runner goes 34 minutes and they go 5 kilometers, they're really doing 6.8 minutes and they're going 1 kilometer. So I now know the speed for this runner per kilometer. We have to look at all the other ones so to figure out which one's the fastest. Runner B. They go 62 minutes and they go 10 kilometers. What I'm going to do, again, it's like we did the other ones, is I'm going to divide the bottom by 10 and I'm going to divide the top by 10. 10 divided by 10 changes to 1. And 62 divided by 10, if you don't know this, go ahead and check it in your calculator. I do know this. It's actually 6.2 minutes. All I do is move the decimal 1 place to the left anytime I divide by 10. So a runner that's going 62 minutes and 10 kilometers is really doing 6.2 minutes for every 1 kilometer. And let's look at the very last runner here. It's 154 minutes for 21 kilometers. We need to change that 21 to the number 1 again. So I'm going to divide by 21, divide by 21. 21 divided by 21 gives me 1. And 154 divided by 21 gives me 7.3, and that 3 is repeating. I'm just going to stop at the 3 because all the other ones went 1 decimal place. So 7.3 minutes. So looking at all these, the one that's fastest is the one that has the smallest amount of time. So the runner that's running the fastest is actually runner B. It's very important in math too sometimes when you're doing answers that you circle them so we know that's the one that's going to be the answer to everything. If that's not the right answer, I'll go back, I'll look at your work. What I want you to do now is I want you to come up with one question that maybe you had on any one of these examples and bring that to class with you tomorrow. We'll cover those questions and then we'll do some more practice in class and see where you're at. Then you're going to have your 3 examples and then you're out of my class for the day. You guys have a good day and I'll see you tomorrow.